Hello students, welcome back to another video of MATHIPHY. In today's video, we will do remaining paper 4 of course code 0625. It's variant 2 May-June 2025. And in this video, we will do question number 6 till question number 10. Question number 6 says figure 6.1 is a full-size diagram of a lens and an image eye of an object. This straight arrow is the image, and here we have a convex lens. The focal length of the lens is 3 centimeter. Part number 1 says on figure 6.1 draw 2 points with label F to show the position of principal focuses, focal points of the lens. So I'll bring my scale, and from the center of the lens I will draw 3 centimeter mark on both sides of the lens and will name that F. 3 centimeter at this side and 3 centimeter at the other side of the lens measuring from the center. And this point is the focal point. Second part says on figure 6.1 draw 2 rays from the image to locate the object. Draw the object and label it as O. If we see the image formation of convex lens, from an image to draw the object, the first ray will pass from the focal point of the lens and go to the lens. After entering the lens, this ray becomes parallel to principal axis. And the other ray will pass from center of the lens and will go undeviated, intersect the first line and will make the object. We will do the same. First ray will pass from the focal point of the lens. When it reaches the center of the lens, it will become parallel to principal axis, and the other ray will pass from the center of the lens and will go undeviated. Where both the lines meet, there would be our object. So I am labeling this as O. Third part of the question says the image is moved so that it is 6 centimeter to the left of the lens. State one characteristic of the image formed when the object is in this position. So we are now moving our object from this position and we will move it to the left side of the lens, and it will be 6 centimeter from the lens. So measuring the 6 centimeter length, that means object would be somewhere here. And this position is the 2F position or second focal point, and whenever we have object at 2F, the image is real, same in size and inverted. I'm writing it over here as well. B part of the question says figure 6.2 shows a simplified diagram of an eye with ray from a near object. The eye needs correction for long-sightedness. Part number 1 says on figure 6.2 draw a path of rays inside the eye to show the effect of long-sightedness. Whenever some person has a long-sightedness, the person is unable to see near objects clearly, and the image is formed behind the retina of the eye. So the first ray will pass from the center of the lens and go undeviated. The next ray, when it reaches the center of the lens, is converged and meet the first ray behind the retina. So is this ray, it will converge after passing through the lens and meet the rays behind the retina. And the point where all three rays intersect is the point where image is formed. Second part says the lens is used to correct long-sightedness. Draw a lens suitable for this correction. A person suffering from long-sightedness uses convex lens to treat it, or we also say a convex lens as a converging lens. So this is the diagram of a converging lens used to treat long-sightedness. Question number 7 says, state what is meant by electric field. Whenever we have a charged body, there is a region around a charged body in which any other charged body experiences a force. For example, if same charge enter into that region, it will experience a force of repulsion. And if different charge enter into this field region, they will attract each other because opposite charges attracts. So electric field is basically a region around a charged body in which other charged body experience a force. B part of the question says a plastic rod is rubbed with a cloth. The plastic rod become negatively charged and the cloth become positively charged. Explain why. So according to question, we have a neutral rod and a cloth, and they both are made to be rubbed against each other. After rubbing, the rod become negatively charged and the cloth become positively charged. Now why is this happened? Because an atom is neutral overall, but when it gains an electron, it becomes negatively charged. And when atom loses an electron, it becomes positively charged. So the atoms of cloth after losing their electrons to rod become positively charged, and rod after gaining the electrons of cloth become negatively charged. So the answer to this question is due to friction, electrons from cloth transfer to the rod, making rod negatively charged and cloth positively charged. Second part of the question says the negatively charged plastic rod is suspended by insulating thread and other negatively charged plastic rod is brought close to the suspended rod. State what happens to the suspended rod. So this negatively charged rod is suspended by insulating thread and another negatively charged rod is brought closer to it. Both have same charges and same charges will repel each other. So the suspended plastic rod will experience a force of repulsion. C part says define kilowatt hours in words. Kilowatt hour. If we break it down, kilo means 1000, watt is the unit of power, and hour is the unit of time. P times T is equal to energy. So it is the energy used by a device of 1000 watt power in 1 hour. I am writing the definition as amount of energy used when a device of 100 watt power is used for 1 hour. Second part of the question says, a small lamp illuminates an electric oven. The lamp has the output power of 25 watt and operates at 220 hours in a year. The potential difference across the lamp is 230 watt. Calculate the energy transferred by the lamp in 1 year and give your answer in kilowatt hour. We have to find the energy. The question has given us the power, which is 25 watt, and the time, which is 220 hours. You know, energy is equals to power multiplied by time. So I will use the same formula. E is equals to P times T. Now the value of P is 25 and the value of T is 220. That means the energy would be 5500. But the units would be, the unit of power is watt and the time is hour. So the unit of energy would be watt hour. But we need the unit is kilowatt hour. So to convert it into kilo, we have to divide this by 1000. So energy would be 5.5 kilowatt hour. Second part says calculate the current in the lamp. To calculate the current, I will use the formula power is equals to current multiplied by voltage. That means current would be equals to power divided by voltage. Power of the lamp is 25 watts and the voltage of the lamp is 230 volts. Dividing 25 by 230, the answer would be 0.109 amps. To two significant figures, the answer would be 0.12 amps. Question number 8 says, figure 8.1 shows a simplified diagram of AC generator. Part number 1 says, state the names of P and Q, X and Y. P and Q are these metal rings and these are known as slip rings. These are used to change the direction of the current after every half cycle so that the coil keep rotating constantly. These X and Y are carbon brushes, and these carbon brushes are used to connect rings and the circuit. So answer is P and Q are slip rings and X and Y are carbon brushes. Part number 2 says explain why EMF is only induced when the coil is turning. To induce an EMF in the coil, we need to constantly change the magnetic flux in the coil. And if the coil keeps turning itself, that means the number of magnetic field of line passing through it constantly changes, flux constantly changes, so EMF is induced in the coil. So the answer is when the coil is rotating, magnetic flux in the coil is changing, that induce EMF in the coil. Third part says state one possible change that caused the larger EMF to be induced. We have already discussed that EMF is induced by changing magnetic flux, or the EMF is induced because the coil is turning or rotating. To produce more EMF, we need to change more flux or rotate the coil more faster. Or we can give other reason that we can use stronger magnetic field. In the B part, we have the circuit diagram. Resistor A, B, C, D are identical. The current in resistor A is 2.4 amps. State the value of current in resistor B and explain your answer. Now let's suppose that the voltage supplied by the battery is V and it's a parallel combination, and in parallel combination the voltage across each junction is same and the current splits at every junction. So that means that the voltage across the first junction, which is connected to a resistor, would be V. This junction would also receive V voltage and the last junction would also receive the V voltage, and the current will split. But B and C, as you see, are in a series combination with each other. In series combination, the voltage splits across each component and the current across each component remains same. As B and C are in series, that means total voltage V is going to split across B and C. As they both are equal, so the voltage division would also be equal. Half of the voltage goes towards B and half goes towards C. And A is receiving full voltage as supplied by the battery V, and D is also receiving the full voltage. The current across resistor A as given by the question is 2.4 amperes, and we have to find the current in resistor B. As resistor A is having full voltage, its current is 2.4, and resistor B is having half voltage, so its current would also be half, it would be 1.2 amperes, and C will also receive 1.2 amperes of current. Why? Because current in series combination is same. That means this complete junction is receiving 1.2 amperes of current, and the above junction of resistor A is having 2.4 amperes of current from the total current, and the last junction would also receive 2.4 amperes of the current from the total current. So answer to first question is 1.2 amperes, and the explanation is resistor B is getting half voltage than resistor A, so its current would also be half. Part number 2 says calculate the value of the current I. Current I means the total current supplied by the battery. So this total current I is going to be split into three junctions, 2.4, 1.2 and again 2.4. That means to get the total current, I will add 2.4, 1.2 and 2.4 amps. And this will give me the total current as 6 amperes. Writing the answer over here as well, the current I is 6 amperes. Third part says the reading on voltmeter is 5 volts Calculate the resistance of resistor A. According to the question, the reading at this voltmeter is 5 volts. That means that this voltage is 5 volt, and the voltage across resistor A would also be 5 volt because they are having the same voltage. To get the resistance of resistor A, I will use Ohm's law. Resistance is equal to voltage over current. Now voltage of resistor A is 5 volt and the current across resistor A is 2.4 amps. Dividing both the values, the resistance will be 2.08 ohms. I'm writing it over here as well. The resistance is 2.08 ohms, or to two significant figure, I will round it off to 2.1 ohms. Question number 9 says, state what is meant by background radiation. Background radiations are the radiations that are present in environment and they come from the natural resources. Second part says, state one source that makes a significant contribution to background radiation. So background radiation can come from rocks, radon gas, cosmic radiations, and many other resources are present in the environment. B part says radioactive isotopes are used in some medical treatments. Radium-223 is an isotope of radium. Radium-223 decays by emission of alpha particles to an isotope of radon. Part 1 says complete the nuclide equation for this decay. Radium has mass number 223 and atomic number 88, and it is going to decay alpha particle and convert into radon. Alpha particle has mass number 4 and atomic number 2. Now to get the atomic and mass number of radon, we have to balance the equation. On this side of the equation, we have mass number which is 223. So what added to 4 will give you 223, and the answer is 219 added to 4 gives 223. Atomic number of radium is 88. Now what added to 2 will give you 88, and the answer is 86. That means atomic number of radon is 86, mass number is 219 and atomic number is 86. Second part says radium-223 is injected into body to treat specific organs. Explain why source must be inside the body. As you know that radium is going to decay alpha particles, and alpha particles have very less penetration ability because of their greater mass. That means they cannot penetrate into the body from outside. That's why we have to use the source inside the body so that they can work. So alpha particles have less penetration, they cannot penetrate from body. C part says isotope of tactinium is injected into the body to detect cancer in one of the organ. The half-life of the isotopes is 6 hours and it decays by emitting gamma radiations. The radiations is detected outside the body. Part 1 says explain why a source of gamma radiations is used. Gamma rays have high penetration ability and they can penetrate into the body from outside, unlike alpha particles that were being used inside the body. So the answer is gamma particles have more penetration to pass from human body and reach the detector. Part number 2 says explain why source with short half-life must be used. A sample with shorter half-life will decay quickly and will not be radioactive for a longer period of time. So the answer is it decays quickly and it will be less harmful for the body. Question number 10 says table 10.1 shows a data for planet A, B, C, D. We have planet A, B, C, D, and we have the data of surface temperature, diameter, and gravitational field strength of these planets. Part 1 says state and explain which of these planets is closest to the Sun. The planet whose surface temperature would be highest and that would be receiving most of the heat from the sun directly would be closest to the sun. That means planet B because it has highest surface temperature and receives most of the heat from the sun. Second part says calculate the surface temperature of planet D in degrees Celsius. Planet D has the temperature of 93 Kelvin and we need to convert it into degrees Celsius. To convert Kelvin into degrees Celsius, we have to subtract 273 from the temperature in Kelvin. I will do the same. I will subtract 273 from 93 and the answer would be negative 180 degrees Celsius. Part number 3 says an object falls through a height of 2 meter on each planet in table 10.1. State and explain on which planet the object falls 2 meter in the shortest time. Ignore any effect due to the atmosphere. If we have any planet and the object is falling from the height of 2 meter towards that planet, the speed of the object falling towards the planet depend upon the gravitational attraction of the planet. The greater the gravitational attraction, with greater speed, it would be accelerating towards the planet. So planet A has the greatest gravitational field strength, which is 23. So it will take the least time. Planet A, due to higher value of gravitational field strength, which is 23 Newton per kg. B part of the question says figure 10.1 shows some of stages in the life cycle of massive star. Firstly, we have a massive star, then it converts into dash. So if we see life cycle of a star, firstly we have a stable star. When it run out of hydrogen, it converted into a red supergiant. So I am writing red supergiant over here. After red supergiant, this is converted into supernova, and then supernova is converted into nebula, which contains dash. So basically we have a supernova over here, and when supernova ran out of its fuel, the outer layer of the supernova explodes and it forms a cloud of dust and gases, which is known as nebula. Nebula mostly contains gases like hydrogen and heavier elements. So the answer is it contains gas such as hydrogen and new heavier elements. Now it says that supernova leaves behind dash or dash. Basically, the outer layer of supernova convert into nebula and core converted into a neutron star or a black hole. So I am writing it leaves behind a neutron star or a black hole. The second part says state the quantity that brightness of supernova in galaxy can be used to determine. The brightness of supernova can be used to determine distance of a far galaxy. Thanks for watching the video. If it was helpful, please hit the like button and subscribe my channel.